Share the screen. All right. And pull up some pseudo paper, virtual paper. And here we go. Maybe here we go. Yeah. Okay, the first kind of factoring we are going to do is what you're going to get as soon as I start heating up my coffee so that I can survive this experience. I will be right back. Well, I know why my alarm didn't work. My phone is dead. Okay. All right, here we go. You probably remember this, but maybe you don't. The first way we're going to talk about factoring is with GCF, the greatest common factor. And a typical example would be this. Okay, there are two terms here. And we have to find out what's the same in each term. Kind of like the old Sesame Street program. I don't know if any of you are old enough to have watched Sesame Street, but they used to sing this little song about one of these things is not like the other, and they would talk about, well, these two things have a lot in common. What's different? Well, here we're looking at these two things are different, but they have a lot in common. What is in common? Okay, so what we're going to do is break these down. You know already that 4 goes into 16, but suppose you don't. Suppose you're just not good at breaking down numbers into their component parts. Let's go back to the very beginning. A calculator can help you. You can start with the number 2, divide it into numbers, and see if 2 goes into those numbers. And if you do that, what you'll find out is that 16 equals 2 times 2. That's probably not big enough, so I'm going to make it bigger. 2 times 2 times 2 times 2, that's what 16 equals. And then we have s squared, which is s times s. And then 4 is 2 times 2, and then times s. So you look at these and you say, okay, each of these have what in common? Well, this has a 2 and this has a 2, and this has a 2 and this has a 2. Okay, and this has an s, So we can find a matching S here. And so what we see these two have together is 2 times 2 times S, which is 4S. We say that this is the GCF. And the position of the GCF is usually in front. So I'm going to do this. I'm going to rewrite 16S squared plus 4S like this. Here's the GCF. Then there are open parentheses. And then we write the leftovers. Like you put the leftovers in the refrigerator, the leftovers go in the parentheses. 2 and 2 and S have been used in this term, so I'm going to mark them out so I don't use them again. And 2 and 2 and S. And it looks like, oh dear, everything is gone in this term, but it's not. There's always a 1. So have faith. Okay. The leftovers are, there's a 2 and a 2 and an S left over. That's 4S. Then there's the plus sign. And then, because it looks like everything is gone in this second term, this is where you have to remember, well, there is a 1. And you put a 1 there. And we have factored 16S squared plus 4S into now 2 factors. This is a factor. It's called the GCF, the greatest common factor. And this is a factor. Okay, family, I heard that beautiful ding sound that says that the microwave has heated up my water. I'm going to get some coffee and be right back. Oh, I'm going to survive. I will not keel over dead. Woo! Okay, look at this, look at this. This makes all the difference. Always keep instant coffee around your house for times like this. Okay, when you suddenly realize you've overslept and what the heck are you gonna do? All right, instant coffee works even if it's not the best stuff in the world. I just heard a ding. Is somebody in the waiting room, I wonder? No. Okay, I hope it's okay. Let me check on you. Yeah, lots of people are here, so we are in the right place, correct?
Yeah, it was a well-earned laugh in there.
It was what now?
a well-earned giggle at your joke.
Oh, okay. Now, if we only had hypodermic needles, you could make some coffee and just stick it in.
God, no kidding. Straight caffeine would be great.
Oh. No, except, I mean, at least it tastes remotely like coffee.
Yes, I like the taste of coffee.
Okay, all right, here we go. Was this understandable? I hope it was. So this is something you want to remember. You put the GCF in front, usually, I mean, there's no law that says you have to, but usually you put the GCF in front and you put the leftovers behind.
So the 1, is that just like always a given?
Yes, because 1 is always there. For instance, 4s squared breaks down into, 4s breaks down into 2 times 2 times s. Well, it also breaks down into 2 times 2 times s times 1. And so the 1 will be there.
Gotcha. Thank you.
Okay, great. Okay, here is a quadratic trinomial, the thing that we're going to be working with more than anything else. 4y squared minus 4y minus 12. Now notice, if you're looking at this, and if not, then I'll just tell you, that the instructions say factor. They don't say solve. At no time are we going to be finding out what y equals. Not today anyway. All we're doing is we're taking this down into its component parts. Here's an example. If you have the number 6, you can take it down into its component parts by saying, okay, 2 times 3. 2 is a factor of 6, and 3 is a factor of 6. Well, we're breaking this down into its factors. The two algebraic expressions you can multiply together to get 4y squared minus 4y minus 12. And if you want to know why, that'll come later. Okay, so, very soon now, you are going to know why we do all this factoring and why we do a lot of the other stuff we're trying to do. Okay, so I am going to break down, let's see, and it doesn't say, interesting, it doesn't say factor by GCF, it says factor, but at this point, technically, it's all you know, even though you know how to factor. So 2 times 2 times y minus 2 times 2 times y minus 2 times 2 times 2. 2 times 2 times 2 times 3. Okay, well, so we have to see what do these guys have in common. And, all right, they all have a 2. And they all have another 2. And this one has 2 y's, this has 1 y, but this doesn't have any y's. This has a 3, and these guys, these terms right here don't have any 3's. So we have found the GCF, it's 2 times 2, which is 4. So I write down, I'd rather write in black. I write down 4 in front, and then what I've always preferred to do is to mark out the GCF because I've already used it. I don't want to use it again. Then I look and see, I have a y times y, which is y squared. I have a minus sign. I have a y. I have a minus sign. And I have a 3. And now I have factored this by the greatest common factor. Now this says factor completely. So let us see, we haven't really talked about the other kind of factoring, but let's see if we could factor this. Y squared minus y minus 3 is 1y squared minus 1y minus 3. Now, my goal when I have a 1 in front of the y squared is to factor the end number and see if I can find any factors that add up to the -1. So let's see. We've got -3, and -3 doesn't factor into a lot. It factors into -1 times 3 and 1 times -3. Now, if I add -1 plus 3, I get 2. And if I add 1 plus -3, I get -2. Nothing will give me a -1. So I have factored this as far as I can factor it. Here's the answer. 4 parentheses y squared minus y minus 3. And a way to check yourself is to redistribute. If you were to take the 4 and multiply it into these parentheses, you would get 4y squared minus 4y minus 12, which is what you started with. So that means your factorization is correct and complete. So that's it. We have done it. Are there any questions? Okay. Then we move on. Let's look for something horrible. Hey, pretty horrible. Something I definitely needed coffee to do. Because here we are, here it is, written larger, -5b to the third power plus 15b minus 30. Now, those of you who remember how to factor and you're pretty good at it, you would say, well, clearly the GCF is 5. And MyMathLab would say, you're wrong. There is another rule that you may not have learned yet. Some of you have probably, most of you have not. And that is, here we have a polynomial. And that is a 3, it really is. The power. Here we have a polynomial. And the highest degree term is 3. In b to the third, here's the highest degree term. The number in front is called the coefficient. And if you read this in the book or like help me solve this or show me an example, you'll see this quoted. So I want to explain to you what it means. The highest degree term should be in front, and therefore it's called the leading term. And the number in front of the variable is called the leading coefficient. And there's a rule you're going to see somewhere that says when the leading coefficient, in fact, I probably should write it. When the leading coefficient, in other words, the number in front, is negative. As this is, it's -5. When the leading coefficient is negative, the GCF, the greatest common factor, must be negative. That complicates things. So, we have to make everything negative. Here's how you do it. I'm going to rewrite this. Now, you're going to do, as you get used to doing this, you're going to do a lot of this in your head. Okay? You're not necessarily writing it down on paper, and it doesn't take as long as when you have a teacher talking through it. You just do it. You don't like it, but you do it. I'm going to rewrite this polynomial temporarily. If you recall, and you might or might not, polynomials are divided by plus signs, and this is the way this polynomial would really look to a mathematician. There's an invisible plus sign right there before that minus sign. Okay, now, so I have one term. Here's a term. Here's a term. And here's a term. This will make it easier, I promise you. This GCF is already negative. In fact, that's the reason I'm going to have to do what I'm doing. But I have to find a negative number to take out of here. Well, that might be hard, but if you remember those nasty rules from pre-algebra of multiplying integers is what it's called, and when you multiply a negative number times a negative number, you get a positive number. Well, 15 is positive, but I know that 15 equals 3 times 5. Aha! But it also equals -3 times -5. That's how you're going to work with these. -3 times -5 times b. Don't want to lose our b. Now this number is already negative, but I do have to take it apart because, you know, I mean, we can see that the common factor is going to be a -5. So I have to get a -5 out of here. -30, if I'm looking for a 5, is going to be -5 times +6, because negative times positive is negative. So -5 times +6. Ooh, there. Now I have a -5 in each term. So I can circle this. You don't really need to circle it unless you need to circle it. It can help if you're not really familiar with doing this. Again, if this is old hat to you, you probably do this in your head. And there may be some students here who do it in their head. But a lot of us, a lot of people really need to see it written out. And that's why I'm doing this. All right, now I have a -5, a -5, and a -5. Yay! Okay. I write down the -5, which is the GCF. Okay, then, because I know myself, and I know that without a full load of 2 cups of coffee, or even with it, I'm liable to forget and rewrite the -5. So we must take steps. My steps, ever since I was in college, is to mark through that -5 because I've already written it in front. And then write the leftovers. B to the third plus -3b plus 6. And it's +6 because the negative got used. Okay, well, everything is great, and MyMathLab would probably count this right, actually. But we don't like to leave a plus, 2 signs right next to each other, right? 2 signs right next to each other. They attract, and what's left is a minus. So we could just view this as a law of physics. Plus and minus are attracting each other, attracting each other, attracting each other, and whoop, they become a minus. Because plus times minus is minus. So plus a -3b would be -3b plus 6. And there we go. Yeah. Now I've been kind of going over this in my head with tricks we're going to talk about later that you've already talked about in intermediate algebra. But like I said, we're going into a very heavy factoring time. And so a complete review is really called for. This can't be factored under usual means, so we're just going to leave it the way it is. And so this is our answer. Here's the GCF, the greatest common factor. And here is what I call the leftovers. And there you go. There you go. It doesn't take as long as it seems to take, because once you get used to the method, you can just kind of zip right through it. If you're like me, you'll never really like it because it is tricky. but nonetheless, you can do it. Let's do another one. So you can see how it works. One example is not good for much. And I'll be posting these, okay? This one, because this is still week 5, this is going to be posted in week 5. In the modules. All the notes and videos are posted in the modules. So it would be worth your while to at least look. Nobody's forcing you to look at it. Just do it for your own good. Okay, we've got negative 4a squared plus 16a. Again, quite obviously, you would say to yourself, well, if you know how to do this, and if you know your numbers pretty well, you would say, well, there's a 4 and 16, so obviously 4 is the GCF, and both terms have at least one a, so 4a is the GCF. But then we have that negative sign to deal with, and it automatically becomes more complicated. So here we go. We have a negative 4 leading coefficient in the highest degree term, which is why it's leading. So I'm going to write this down as negative 4 times a plus. Here is 16. Well, 16 is 4 times 4. It's a perfect square. It's probably my favorite perfect square. For some reason, I like 4 times 4. Okay, well, 16 is 4 times 4. And normally, I might write this as 4 times 4 times a in a GCF problem, where there's also a 4 in the first term, so I can just pull out a 4 as a GCF. But it's not that easy because of the negative, and here's where I have to remember that negative times negative is positive. So positive 16 can be written as negative 4 times negative 4. Now I'm ready to factor. Each term has a negative 4. Each term has an a. Therefore, my GCF is going to be negative 4a. Parentheses for the leftovers. But as always, I like to mark out the numbers I've already used so I do not use them again. You might or might not have to do that. There's a leftover here in the first term, a. Oops, I didn't mark out that a. That's dangerous. Okay, here's a. It's a leftover. Plus. And a negative 4. Cool. Now I'm going to rewrite this because we have two signs next to each other and it's just not normal looking. When you've got a plus and a minus next to each other, remember your math tables, a positive number times a negative number is negative, or plus times minus is negative. Which when you were first using it, you might have recited that in school. Plus times minus is negative, or plus times minus is minus, like that. Reciting, as silly as it might seem, if you've got kids, you're allowed to be silly. Or if you've ever had kids, you're allowed to be silly. So making up little rhymes and stuff is the best way to remember. I'm sure in high school you studied or at least heard about ancient Greek poems that now go on for thousands of pages. But how people remembered those was they made them into songs. Anybody can remember a song. We go around singing songs all day long. The best way to memorize that seems to be genetic in the human person is to make songs and then sing them over and over. So whatever you have trouble memorizing, make it into a song and sing it over and over. Especially, you can give it a beat of some kind if you want to. It's one way of memorizing, and it's a recognized method that always works no matter who you are. Okay. Anyway, that's our answer now. Here's our GCF, and here are the leftovers. Okay, I'm going to ask for questions. Or is this doable? It's got to be doable. Okay. You can always see me later. I have office hours from 3 to 6. My dog hates them. I'm not living up to my purpose in life to my dog during my office hours because I look like I'm not doing anything and I should be therefore giving all my attention to her. It's very simple. Now we're going to go on to a different kind of GCF, but it's still a GCF. Oh, well, okay. No, we're going to jump right to the next kind of problem. So, here it is. Well, and it is kind of different because look how ugly this is. The highest power is 4. You don't see a lot of those, not in school. This is called a quartic. This is a quartic polynomial. You treat it like any other polynomial, but it's called a quartic. Okay, also, remember the invisible 1? So this is -1 times x to the 4th, minus 1 times x to the 3rd, minus 2x squared, plus 4. That's what that is. So what I'm going to do is write this with the invisible plus signs. Because polynomials are really separated by plus signs. That is, the terms in the polynomials are really separated by plus signs. So even when you're subtracting, it looks like a plus sign. Or there is one there, even though it's invisible. So this is what we really have here, and I'm going to rewrite it as -1 x to the 4th plus -1 x to the 3rd plus -2 x squared plus 4. We have 1, 2, 3, 4 terms, and the leading coefficient is negative. Well, with this already, well, no, okay, we are going, we are going to have to remove a -1 because -1 is the GCF, so I need to write this accordingly. I've got -1 times x to the 4th plus -1 times x to the 3rd plus -2 times x squared plus, here's the problem guy, 4 is the same thing as 4 times 1, but it's also -4 times -1, because negative times negative is positive, and there's always a 1 there. So I'm going to rewrite 4 as -1 times -4. Now I can see that all 4, and look at -2. No, I messed that up. -2. -2 equals, well, you get a negative by multiplying a negative and a positive. So -2 is -1 times 2, because I'm looking for the -1. I could also say 1 times -2, but that's where I'm at right now, and I want to take a -1 out of every term, so I have to have the -1 there. So -1 times -2. No, that's a lie. I need more coffee. The price of oversleeping. Get rid of it, do it again. -2, the combination I want to use is this combination right here. -1 times +2. So I'll write that right here, -1 times +2. There now. This is the way I want it so that I can factor a -1 out to the front. So -1, -1, -1, -1. The -1 gets written in front. And then parentheses for all these leftovers. I'll have x to, oh, I want to mark that out. X to the 4th plus x to the 3rd plus 2x squared plus -4. Almost done. All right, so my -1 is going to turn into a negative, just a negative sign. Remember, when we're multiplying a 1, it often disappears. So x to the 4th plus x to the 3rd plus 2x squared, plus times minus is minus, so -4. And there is my answer. This says factor out a common factor, and that's it. Okay. Now, we're going to take GCF to a new level. Because it had to happen. Everything in algebra starts basic and then you move to a higher and higher level of difficulty. Okay, here we go. Here we have a cubic polynomial, r to the third minus 3r squared plus 3r minus 9. Now, what I would most like is to pull out a GCF, because that's what we've been doing, a GCF from all 4 terms. This is a cubic, by the way, a cubic polynomial. But I'm going to just call it a poly, in the interest of time. We are going to use, are we? Yes, we are. We are going to use a method of factoring on this called factor by grouping. Actually, that G should be a capital because this is a proper name. It's a proper title. Factor by grouping. Now in math, really everything stands for something else. Grouping has a particular meaning, implication, and that is you got to group with parentheses. Here's how you factor 4 terms by grouping. In fact, you can really only factor 4 terms by grouping if you're going to factor them, or you can try to. I take the first 2 terms and I group them together with parentheses. And I take the second 2 terms and I group them together with parentheses. It's very important that you leave your plus sign in the middle. It doesn't belong to this set of parentheses, and this plus sign does not belong to this set of parentheses. It stays in the middle, and you can't forget it. Don't forget to write it, because if you did forget to write it, you would naturally assume that you were supposed to be multiplying those, and you would get the wrong answer. So, always put a plus sign there. Okay. Now, I'm going to work inside the first term, and I'm going to pretend for a little bit that the second set of parentheses is not there. I mean, work inside the first set of parentheses. And what I'm going to do is I'm going to break down each term in the first set of parentheses. R times R times R minus 3 times R times R. And I need to pull out a GCF. So there's an R in both terms and another R in both terms. And that's it. So R times R, which is R squared, R times R is my GCF. So I write down R squared, and then I write empty parentheses, And then I mark out what I've circled so I don't use it again. And then I start looking for leftovers. I have R minus 3. And I have just factored that first set of parentheses by GCF. Okay, now I'm going to do the same thing over again, but I'm going to do that with the second set of parentheses.
Miss
Somebody
Wilmot,
say yes?
shouldn't the
Oh,
first be
yes.
squared?
Thank you, thank you. There, perfect, thank you. I now am going to look for a GCF in these two terms. Well, 3 times R is not going to break down, but I know that 9 equals 3 times 3. So I can pretty well see right away that my GCF is a 3. So I write down 3 and open parentheses, mark out the numbers I've circled, and then write down R minus 3. I'm not done. I'm not done. I am now going to explain that this is a weird-looking polynomial in which this is the first term and this is the second term. Because r squared and r minus 3 are multiplied, 3 and r minus 3 are multiplied, and they're separated by a plus sign. Well, in polynomials, polynomials are made up of terms, and inside a term, all the numbers and variables, numbers and variables, letters in other words, are multiplied or divided. And if you say, well, no, you've got subtraction going on, remember that r minus 3 is grouped together as one thing. So you have r squared times this one thing. So this is a kind of polynomial in which you have two terms separated by a plus sign. For that reason, I can look at this term and I can look at this term and ask myself, what is the same? What is the same on both sides of this polynomial, in both terms of this polynomial? And the answer is r minus 3. Look at this. R minus 3 in the first term and r minus 3 in the second term. That now is your GCF. It's a weird looking GCF. It's a binomial, but it's grouped together as one thing, so it's a GCF. I'm going to write down the new GCF. r minus 3. And open parentheses for the leftovers. I'm going to mark out the circled terms. And then I'm going to write what's left, r squared plus 3. Okay, well, how do I know that's right? And the answer is that I multiply them together, which I would do if we didn't just have 10 minutes left, and I have to show you factoring by grouping in a slightly more complicated form. This form right here. And what makes it more complicated? It's not a lot more complicated, it's just a little more complicated. Okay, it's a cubic again, a 4-term cubic polynomial. X to the third plus 3x squared minus 5x minus 15. Now, the instructions say factor by grouping, but you always check to see if there's a GCF in each term that you can pull out first, but there is not one here. 3 terms have X's, but 1 doesn't. Yeah, that would be the only contender here. There's a 3 in 15. And there's a 3 there, but not in the other terms. So no, there is no GCF for all 4 terms. So I'm going to factor by grouping now. I take the first 2 terms. And I put them in parentheses. And watch this. I write a plus sign. And then in the second 2 terms, I write negative 5x minus 15. And now I'm ready to factor by grouping. The first term is pretty straightforward. This is x times x times x plus 3 times x times x. And I can see right away that each term contains an x squared, an x times x. So I'll circle x times x, and I will circle x times x. And I will write that out in front because that's what you do with a GCF. And then write open parentheses for the leftovers. And I'm going to mark out what I've circled so I don't use it again. And then I'm going to write down the leftovers, x plus 3. And the first part's done. Now I write down my plus sign and write down my plus sign. The most common mistake is to leave off the plus sign. Never leave off your plus sign. Now here, what makes this a little more complicated is that inside here you have a binomial, which is a 2-term polynomial. And the leading coefficient is negative, which means the GCF you pull out of these 2 terms has to be negative. So I'll have a negative 5x here plus this negative 15. Well, I know 15 is 5 times 3. So negative 15 is going to be, well, I could write it, I am going to write it negative 5 times 3. But, you know, it would also be true to write it 5 times negative 3, except I need a negative 5. So I have to go with this version right here. Negative 5 times positive 3. Now, I'm going to circle the negative 5 and write it out front of these parentheses. And then open parentheses for the leftovers. I mark through what I've circled. And I can see now that my leftovers are x plus 3. Okay. Now, you can think of this plus sign as separating two sides of a polynomial, or the two terms of a polynomial, because it is. Here's a term and here's a term, and both of these terms have the same thing in them, parentheses x plus 3. Parentheses x plus 3 is the GCF. So I write it out front. I should have circled it because I want to stay consistent. Okay, and then I mark through the GCF I circled. And what's left here, I open parentheses for GCF. X squared is my GCF from the first term. And plus a minus 5 is my other GCF. Well, positive times negative is negative, so this will be minus 5. Oop, except that's an x squared. And I keep trying to lose that squared. And so I am done. Later in the semester, you're going to find out you can actually factor that, but it's not pretty. And we'll do that later in the semester, but not now. But okay, your solution is x plus 3 in parentheses times in parentheses x, not solution. It's not a solution, it's a factorization. X plus 3 times x squared minus 5. And that is factoring by grouping. On Monday, we're going to take a 3-term polynomial. And we're going to turn it into a 4-term polynomial. That is, how we're going to do this is x squared stays the same and 2 stays the same. But this 3x is going to split apart into two other terms. We're going to turn this into a 4-term polynomial. There's a method. And then we're going to factor it by grouping. So the best favor you could do for yourself after you take the exam, if you haven't taken it already, and a lot of people have taken it already, today's the last day, that is to take attempt 1, and then you can take attempt 2 anytime during the semester. At first I said you had to do it next week, but I changed my mind. So that's pushing it too hard. But you can take make your second attempt anytime during the semester. And MyMathLab will take whichever is your highest score and use that to calculate your score. Okay. As a result, since your scores are in, your scores are in Canvas, what I'm going to have to do is I am going to have to take your highest score, your higher score of the 2 attempts, and use that as the only score in Canvas, because Canvas will average them. We don't want that. We want the highest score used, the higher score used. So that's what'll happen later, but that's later. Right now, I'm going to feed my poor dog and take her for a walk. And then I'm going to come home and I will sync, SYNC, your scores from MyMathLab into Canvas, so you can see what your score is now that you've taken the exam. And if you haven't taken the exam, well, I'll sync them again tomorrow and you'll be able to see then. Okay. We are done, and I have to go ahead and leave and take care of my dog before she has a great big accident on the floor. But I will be back. Yeah, I will be back at 3, okay? And you can come by and ask all the questions you want. Or let me tell the people who've already taken the test and be speaking to the people who haven't. When you do take the test, you can go into MyMathLab, go into the grade book, not only see your grade, but you can click on review beside exam 1 and you can see what your answer was and no, that's not true. Starting tomorrow, you can go into gradebook and you can see what your answer was on a particular test and what the answer should have been. Okay, and pardon me?
You can see your answers and stuff to this all right now.
Can you do it now?
Yeah.
Oh, great. Okay. Well, that's good. Usually it's after the due date, and the due date's today. But anyway, yes, go study for the exam and make an A.
It says it's past due.
Cool. No, it's not past due. You can still do it. But I will go in and adjust the date just to make sure you can still do it. You can still do it today. Okay, and then I'm going to have to readjust it, and you can take it all throughout the term. I mean, you can retake it if you want to. You don't have to make a second attempt. Unless you're unhappy with your grade, then you can make a second attempt. But I recommend you study more first. Okay, I will see you later, okay? Email me with questions, or see me at 3, or make an appointment for a different time, but right now I really have got to take care of my dog. It's all my fault. I overslept and I don't want a big pile on my floor.
Have a great day.
Yeah,
All right, thank
bye-bye.
you.
And thank you for coming by.
Thank you.